video, we will learn about 8.2 asymptote, which is to find the horizontal asymptotes. So as you can see here, this is the horizontal asymptote. This is your horizontal asymptote, which is y equals to b. So a line y equals to b is a horizontal asymptote if either limit fx when x approach to positive infinity equals to a constant, or limit x approach to negative infinity fx equals to a constant. So let's see example 11. The question asks to determine the horizontal asymptotes of a function fx equals to x over x minus 2. Okay, now let's recap on the previous video where we learned limit x approach to positive or negative infinity fx. If we substitute infinity into our function and we get infinity over infinity, what we need to do is we have to divide by the highest power of the denominator. Divide by highest power of denominator. So as you can see from the question here, we need to separate limit x approach to positive infinity and limit x approach to negative infinity, as you can see from the definition here. So we have to do two parts here. So let's do the first part where we need to find limit fx when x approach to positive infinity. So our fx is x over x minus 2. So now if we substitute infinity into this function, we will get infinity over infinity. So what we have to do is to divide by the highest power of the denominator. So as you can see, the denominator here is x minus 2. So the highest power is x. The highest power of the denominator is x. So we have to divide each term by x. So we now have limit x approach to positive infinity. Here we will get x over x over x minus 2 over x. So now just simplify. Limit x approach to positive infinity. Here we will get x over x. We will have 1 over 1 minus 2 over x. Okay, now just substitute the value of infinity into 1. We will get constant equals to 1. And the other one here is still 1. And substitute the infinity into 2 over x. Again, the next rule where we have limit x approach to positive or negative infinity fx, a over x, you will get 0. So here we will get 0. Minus 2 over infinity, therefore this will be 0. So 1 over 1 minus 0 equals to 1. Now that's the first part. Now the second part we need to do for limit x approach to negative infinity. X over x minus 2, your function. So we need to do two parts here. So we need to do two parts. Okay. So now again, we just do the same thing, divide by the highest power of the denominator. So we will get limit x approach to negative infinity, x over x minus 2 over x. So again, the same thing, just simplify. Limit x approach to negative infinity, we will get 1 over 1 minus 2 over x. And your final answer will be 1 as well. So now we can conclude that limit x approach to positive infinity equals to 1, which is a constant. Limit x approach to negative infinity equals to 1. So therefore, we have to do the conclusion where y equals to 1 is a horizontal asymptote for fx. Okay. So let's see the next example. Example 11, we have to determine the horizontal asymptote of fx equals to 3x over square root x square minus 1. So in the previous video, we already did this kind of example where we have square root x square minus 1 minus 9, this is a special case where we have to factorize x squared. So now we need to factorize x squared. We will get limit x approach to positive infinity. We have 3x over, okay, so factorize square root x squared. Factorize square root x squared. So this one we will get 1 minus 9 over x squared. So check square root x squared times 1, we will get x squared times 9 over x squared, we will get 9. So okay. So now again the definition, as I explained in the previous video, we have square root x equals to positive x, negative x, positive x for x approach to positive infinity, negative x for x approach to negative infinity. So now we have limit x approach to positive infinity. So square root x squared here we will change into positive x because we have x approach to positive infinity. So now we will have limit x approach to positive infinity, 3x. So square root x squared will change into positive x. And this one is 1 minus 9 over x squared. So we don't need to write the positive. So this is just positive x. So now again, we have to divide by the highest power of the denominator. This is positive infinity. So divide by the highest power of denominator. As you can see, the highest power of denominator is x. So we have to divide each term by x. So we will have limit x approach to positive infinity, 3x over x over x square root 1 minus 9 over x squared. So simplify, we will get limit x approach to positive infinity, 3x over x, we will get 3 over, this one will be 1, here 1 minus 9 over x squared. So just substitute the value of infinity into 3, just a constant, that will be 3 over square root 1 minus 9 over x squared. So 9 over x squared is 0. So 1 minus 0. So this we will get 3 equals to 3. So we haven't finished yet because we have to do the second part, which is limit x approach to negative infinity. So we have to do the second part where limit x approach to negative infinity. So now we have limit x approach to negative infinity, 3x over square root 1 minus square root x squared minus 9. So we do the exact same thing where we factorize square root x squared 1 minus 9 over x squared. So the difference here is, as you can see, the square root x squared here, we have x approach to negative infinity. So as you can see from the definition here, square root x squared equals to negative x when x approach to negative infinity. So we need to substitute square root x squared as negative x. So now we will have limit x. We'll have limit x approach to negative infinity, 3x over, this will be negative x times square root 1 minus 9 over x squared. So again, the same thing, we have limit x approach to negative infinity, divide by the highest power of the denominator, which is x. So we will have 3x over x over negative x over x square root 1 minus 9 over x squared. Okay, now we just simplify. We have limit x approach to negative infinity, 3 over negative 1 minus 9 over x squared. Okay, again, substitute infinity into 3, we'll get 3 over, now we have negative square root 1 minus 0. So your final answer will be 3 over negative square root 1 is negative 3. So now we already have limit x approach to positive infinity and limit x approach to negative infinity. So we can conclude that y equals to 3 and y equals to negative 3 negative 3 horizontal asymptote.